Alright, in this example, we're going to use z-scores, or standardized scores, in order to help us look and compare at leg press performance and bench press performance. So one way to look at how somebody can perform on two completely different tasks, but see if they're better at bench press or if they're better at leg press. So, just as a review, remember, z-scores or a z-distribution, they fall in a normal distribution. So we have, I should be drawing our normal curve, which means it is symmetric, it is asymptotic where the tails go out to infinity, and the area under the curve is 1.0, and the mean, median, and mode all fall right here in the middle. Specifically, a z-distribution has a mean of 0 and a standard deviation of 1. And the other helpful thing to know is that if you have an x-score that is greater than the mean, then your z, so if it's greater than the mean, then your z-score will be positive. If your x-score is less than the mean, then your z-score will be negative. And if your x-score equals the mean, because the mean equals 0, then your z-score will also equal 0. So just having that review will help us set up our example. So in our example, we're going to start out and we're going to look at our person is a female lacrosse player, and she's playing lacrosse, and they just tested bench press for upper body strength and leg press for lower body strength. She was able to lift 112 pounds for her bench press, and she was able to leg press 195 pounds. In both cases, she did better than the mean. For her team, overall, on average, they were able to bench 100 pounds, so she did 12 pounds better than the mean. In leg press, she was able to leg press 175 pounds, so here she did 20 pounds better than the mean. So pound-wise, she looks like she's better at leg press than bench press, but that doesn't take into account the differences in standard deviation. So the standard deviation for bench press was 5.5 pounds. The standard deviation for leg press was 12.5 pounds. So using that information, now that we have our person's x-score, or what they bench pressed or leg pressed, the team's mean, and the team's standard deviation, I can calculate z-scores. So I look at the z-score, the standardized score for her bench press. I do 112 minus the 100-pound mean, all over a standard deviation of 5.5 pounds. And I put that in my calculator, and I get a z for bench press of 2.18. When I do it for leg press, I put in the 195 for her x value, minus the mean of 175, all over a standard deviation of 12.5. I throw those values in my calculator, and I get a z for leg press of 1.6. So I'm going to take those and say, alright, I have, even though the variability from the mean was smaller in bench press, she actually performed much better in bench press than she did in leg press, because she has a 2.18 on bench press and a 1.6 on leg press. And we can see that even more clearly on our interpretive curve. So if we go to our interpretive curve, we have our z-distribution here. Z-distribution. Again, we have a mean of 0, a standard deviation of 1. In our leg press, she scored her bench press, she scored a 2.18. So we'll draw it right around there. Z equals 2.18, and that was bench. We'll switch over the color to red for leg press. She scored a 1.6. So 0 for leg press, 1.6. So we can see that she scored higher. Also, one of the other things we know about a normal curve is that the distance between one standard deviation is 68%. The distance between two standard deviations is 95%, and the distance between 3 standard deviations is 99%. You can see that with this 1.6, she's still above. Let me see if I can do a nice little. Here we go. With this 1.6, she's still above that middle 68%, but she is, not quite in a positive outlier range. The 2.18, she is better than 90, or not only 95% between 2 standard deviations, but this additional 2.5% beyond. So she is outperforming about 97% of her teammates. She's probably one of the best performers, maybe the best performer on her team in bench press. So we can tell that she's actually very good at bench press, and she's already good at leg press. So hopefully this example is useful for you. There'll be other video examples through the semester to help you out with some of the concepts we work with.